Hi, in this short video I'm going to show you how we can use packet captures, specifically with Zscaler private access, to understand what's going on with application traffic. Now this video does include some customer data, so it shouldn't be shared outside of Zscaler. First off, this is running a packet capture from within Zscaler app. Customer is deployed with tunnel mode, lightweight filter, and therefore it kind of mangles the source IP and destination IP and source port information. So it makes it kind of difficult to read. That'll get fixed in 152, but just to kind of show you an example, here's the DNS query from the client to the DNS server for the SCCM host. If you look here, the source port 65245, the actual response appears to be from the same packet. And we just mangle the source port, so we can't really see the DNS traffic. But we know the DNS traffic here actually results in this going to 164.1.6 because these last 4 octets in the packet capture are the responding IP address. So let's go ahead and we'll filter on this IP address 164.1.0/24. And so sin, ac, it's still mangled traffic here. But what's going to happen here is the client's going to post some data, and we can see there's some odd, spurious data in here. And the server is then going to respond. There's some line data in here. Which is all details of the application, and then there's this same kind of mangled data in here, and I'm going to help you understand what that mangled data is. So let's go ahead, and what we're going to do is we're going to click on those bytes, we're going to export those bytes, and we're going to save it into my downloads, and we're going to call it file.raw. Let's replace that. The interesting thing about file.raw that I know because it's SCCM traffic is that it is simply gzipped encoded data. So if I print some magic bytes onto the front of it to identify it as gzip traffic, and then I concatenate that file onto it and run it through gzip, I can actually decode it. And what this is telling me is that the client is part of this Active Directory site. That's where they believe they are, their forest. But what's actually happening is the client posts its IP address, the actual IP address from the machine. We know about the 169.254 address. We also know the subnet, and we know that it's 192.168.1.3 because we see that over here. So the application running on the client's machine is saying, hey, my IP address is 192.168.1.3. It is also saying its Active Directory site is this one in Ashburn. And SCCM will function in 2 methods. It's either configured to understand what the site is, which is an Active Directory property, or the boundary, which is the IP address the client sends. So what does that mean? Because obviously ZPA does a NAT. The client is only ever presented behind the IP address of the connector. So let's take a look at this response data. And what we're going to do is we're going to do exactly the same thing. Export the bytes. We're going to call it file.raw. We're going to overwrite it, replace that file, and bounce the same thing back through. And in this case, it says, okay, great. I kind of don't really know where you are because 192.168.1.3 is not on the customer's network. And basically all it says in this is somewhere in here, it's basically saying, your subnets are not in this range. Don't know whether or not you're actually able to see the network. And in here, it says, hey, fall back to this server. I don't know where you are. And the fallback server could be a distribution point. This is a distribution point failback. But it leaves the client then in this kind of zombie state where it's, hey, you're on the network because you can talk to the SCCM server, but you're not on the network because you're in an IP range which is not something I'm familiar with. And the answer to it might be to actually move SCCM to use sites, or to use SCCM to say, hey, every RFC 1918 address is a boundary, and therefore no matter where the user is, as long as they're in a private network, they can get to the SCCM server. Or it might be to configure a fallback distribution point that can actually service the content and deliver it to the clients. So yeah, very specific to SCCM in this case, contextual to this specific customer. Every customer's SCCM configuration is different, but it's important for us to understand as engineers, how is the customer's Active Directory configured? How does ZPA function in this natted kind of environment as we move to zero trust? And how do we provide context to customers on how to configure their applications, their endpoints, and their servers to work in this zero trust environment where the network should become irrelevant and metadata, data about the network, becomes more relevant. Thank you.